going over mole ratios. Okay, so here's a question that was a bit problematic. So in a laboratory investigation, a solution that contains 13.2 grams of lead nitrate reacts completely with a solution that contains 12.0 grams of sodium iodide, producing 18.4 grams of lead iodide and an undetermined mass of a second product, sodium nitrate. This reaction is represented by the balanced equation below. So balanced equation means the coefficients are correct. It shows conservation of mass of matter. The mass of NaNO3 produced is how many grams? So this question is testing your understanding of the law of conservation of mass. What does that mean? That the mass of the reactants must equal the mass of the products. So if the mass of the reactants is 10 grams in total, the mass of the products must also be 10 grams in total. So let's see what we have. For lead nitrate, we have 13.2 grams, right? For sodium iodide, we have 12.0 grams. Right, so if we add those together, that's how much we have on the reactant side. So that is 25.2, correct? Okay. On this side, we have 18.4 grams of PbI2, that's lead iodide, and an undetermined amount of this. So how do we find the mass of this? Well, we know that on this side, the mass is 25.2 grams. So the mass on the product side also must be 25.2 grams because of the law of conservation of mass. So that means if this is 18.4 grams, how do we find the mass of this? We would do this subtraction problem, right? 25.2 minus 18.4 to get the answer for the mass of the sodium nitrate, right? So it would be 6.8 grams because it's literally just doing this subtraction problem. All right, another problem with mole ratios, this tied into some of those concepts. It tests your understanding of the parts of an equation. So the coefficients in a balanced chemical equation. Where are the coefficients? Here's one. Here's one. What do they represent? Is it the total number of elements in the reaction? No, not at all. Is it the mole ratios of the substances in the reaction? Is it the total number of electrons in the reaction? Or is it the mass ratios of the substances in the reaction? If you remember, we were doing things like this to check the ratios, right? But were we doing mass ratios or mole ratios? Do you remember? Yeah, it's mole ratios. So coefficients tell us moles, just like subscripts tell us moles in a compound. Coefficients tell us moles in a balanced equation. All right, this question is testing your understanding of mole ratio calculations using balanced chemical equations. So given the reaction that you see there, how many moles, so here's the reaction, how many moles of KClO3 must completely react to produce 6 moles of O2? So I have one number, 6 moles of O2. I'm trying to find how many moles of KClO3, right? So what I need to do is set a proportion, and I need moles of O2 to be on the top and moles of KClO3 to be on the bottom. And then I go to the balanced equation. Find O2. What is its coefficient? 3. Find KClO3. What is its coefficient? 2. All right, now let's cross multiply. So 6 times 2 equals 3 times my question mark, right? So that's 12 equals 3 question mark, divide both sides by 3, and I get as my answer 4. All right, now we had a few organic reactions play posit questions I want to go over. All right, so this question is important because it had an error in the key, so I want to make sure I address this. So it says, given this reaction where I have this compound, organic because it contains carbon and hydrogen, and then on this side I have this with that plus this. So this OH, when I've got carbons and hydrogens with it, is an alcohol plus CO2. So what is that? Saponification is making soap. Do I see OH on the reactant side? And it would have to be with a metal, like NaOH, for example. No. Do I see an ester? No, that's the functional group for an alcohol, not an ester. Maybe, let's see, polymerization. That's where I get a bunch of little things all joined together. No, this is fermentation, where I get an alcohol, a carbon, hydrogen with OH, and then I also get carbon dioxide. So that should be fermentation. All right, this equation, it tested your ability to find the missing product in a balanced chemical equation or on your knowledge of combustion, because it told you that it was a combustion reaction. So given the incomplete equation for the combustion of ethane, what is the formula of the missing product? And these were the answers that you were given to choose from. So we burned stuff in class, right? What did we get as the products? What did we see forming on the inside of the glass? Do you remember? Yeah, it was water, right? Water vapor. How you could do it math-wise is, look, there's 2 times 2, that's 4 C's. Over here, there's 4 C's. So carbon is all accounted for, right? Then count up the hydrogens and count up the oxygens, and then realize I have 6 of them. So you could kind of get there, but that's a long way. If you just remember combustion, carbon dioxide and water are the products. All right, now questions from the balancing practice sheet, okay? So here's one, it's just balancing, so let's go over it, okay? So we have Ag, we have S, and we have Al. So and then I'm gonna divide, here's the other side, we have Ag, we have, let's put it in the same order, oops. Let's put it in the same order. All right, Ag, S, Al. Now let's count. 2, 1, 1, 1, 3, 2. Okay, well, nothing really is balanced at the moment, right? So how do I want to approach it? Well, if I try to balance Ag first, all I would do is put a 2 right here. That doesn't really help anything else, right? So let's try the sulfur next. So a 3 is here. Okay, let's try that. So let's put a 3 here. So that would multiply sulfur times 3, which would give me 3. Perfect. But this 3 gets distributed, so the Ag is also multiplied by 3, which gives me 6. Okay, so sulfur is balanced. Ag is not. Can I fix that? Sure can. How? Multiply it times 6. Right, so that 6 is the coefficient here. What about Al? Times 2 is 2, and put the 2 here. So I can leave this line blank or put a 1, okay? All right, so now let's look at this one. Ooh, this, I'm just gonna write this over here. That looked like it was a whole nother line. But that doesn't matter for balancing the equation anyway, because I'm only looking at the chemical formulas. So I have N, I have H, and I have O. Now I have, that's it. And then here's the other side. I have N, H, O. All right, so N I have 1, H I have 3, O I have 2. Here I have 1 N, 2 H's, and then O is 1 plus 1, which is 2. Okay, well, my H's don't balance. The nitrogens are fine and the oxygens are fine, so I got to fix hydrogen, right? Well, this is an odd even pair, so the best bet is to multiply this by 2 to make it even, right? So when I do that, right, it doesn't just change hydrogen, it also changes nitrogen. So now nitrogen is wrong. Fix that. Okay, when I do that, right, I'm going to multiply this times 2, and I get 2. That's also times 2 is 2, so that total is 3. Okay, well, I need to fix the H's, right? So times 3 is 6, so times 3, right? But that also multiplies this times 3, which is 3, which makes this 5. Well, great. I'm not a fan of this. Why? Because I can't multiply 2 by a whole number to get to 5. I could multiply it by 2.5, right? And that gives me 5, so that's 2.5. So at that point, everything is balanced, but I can't have a half. It's got to be a whole number, right? So what I could do is try again, try with a bigger number, or realize that what that means is all of these numbers are right. Everything is balanced, except this is a fraction. So if I multiply this by 2 and get 5, right, I would have to then multiply everything else by 2. So that would be 4, 4, and 6. And then everything would be balanced. Look, 4 nitrogens, 4 nitrogens. 4 times 3 is 12 hydrogens. 6 times 2 is 12 hydrogens. This is 10 oxygens, and I have 4 of them here and 6 of them here. So this was a very tough one, and this is kind of my recommended strategy when you realize that you can't get it to be an odd number, so it's a half, and then realizing that means actually I'm just going to need to go up and double everything. All right, now questions from the formula practice sheet. This question is just testing your understanding of formulas. Write the empirical formula. So let's count it out first. C3, H, 1, 2, 3, 4, 5, 6. O, there's only one of them. So if I want to reduce it, I got to look at the ratio. 3 to 6 to 1. Can I reduce that? No, no, no. So this is the correct answer. Okay? Now look at this one. So chemical analysis of a liquid shows that gives me a bunch of percents and some elements. Calculate the empirical formula. So this is just testing, do you know how to do this? So magnesium, oxygen, and sulfur. So magnesium is 20.2%, so we're going to call that grams. Oxygen is 53.2%, so we're going to call that grams. Sulfur is 26.6%, so we're going to call that grams. Okay, then what? We know that the mole formula says in order to find moles, because I need moles in a formula, right? In order to find moles, I have to do grams divided by gram formula mass. So for magnesium, that is 24.3. Okay, so you do 20.2 divided by 24.3, and you get 0.83126. All right, then we do for oxygen divided by 16. So we do 53.2 divided by 16, and we get 3.325. And then sulfur is divided by 32.1. So 26.6 divided by 32.1 equals 0.82866. All right, now I'm going to write that as a formula. Okay, so what will it look like? Let's write it right here. So G 0.83126, O 3.325, S 0.82866. Well, that is nonsense, right? You should recognize that as nonsense. So what I need to do, if you remember, is make one of those be 1. Which one do I want to make 1? The smallest number. So I take the smallest number and divide it by itself, right? Which will give me 1. So I know it's going to be S1. But I need to take this one and divide it by that same number. So 82866, and divide this one by 0.82866 and see what I get. So let's see what I get for mg. I take that 0.831 to 0.8321 divided by 0.82866, and I get 1.0031, and then for O, 3.325 divided by 0.82866 equals 4.012. So now these are not whole numbers, but they're pretty close, right? So it's going to be MgO4S. Now in the right order, it's literally MgSO4, but you don't have to write it like that. This is what the numbers reach out to. So there you go. All right, and our last problem here is solving for a molecular formula from an empirical formula and the gram formula mass. So it says we have this empirical formula and the molecule has a mass of this. So let's find the gram formula mass of this. 1, 12, 16 times 2. That's 32, right? So 32 plus 12 plus 1 is 45, correct? All right, is 45 equal to 90? No, it is not. What do I need to do? Let's do, I just wrote that as badly. 90 divided by 45. What does that give me? A 2. So the real molecule is twice as big. So the original molecule is HCO2. That's the empirical formula. So what do I need to do? Take all of those subscripts and multiply them by 2 because the real molecule is twice as big. So I will get H2C2O4. Ta-da! And there's the molecular formula. And then don't reduce it. I know you can reduce it, but we already got the empirical formula. We're trying to get the molecular. So that's it. There you go.